Okay, so the last topic covered in your chapter that I wanted to go through this week is around expectancy effects. So let's talk about placebo effects first. Placebo effects are when someone takes a sugar pill or engages in a non-therapy that they believe to be effective, but that actually makes them feel better. And this is a phenomenon that we've measured before. It's one of the reasons why it took such a long time for good medicine to get a strong toehold, because people were selling all sorts of things they claimed to be cures. People would take them, believe them to make them feel better, and would actually feel a little bit better. It's a psychological phenomenon. So when we do drug studies, it's important to understand that underlying that is the concept that sometimes just the act of taking a pill can make people feel better because it's taking a pill that they believe will make them feel better. So when people do placebo studies, for example, it's important that participants either take a pill with active ingredients or take a pill with inactive ingredients, so that the act of taking a pill is consistent across both groups, and the benefits of just taking a pill, regardless of whether it has active ingredients, is controlled for. So you can compare taking the inactive ingredient pill to the active ingredient pill, and if there is improvement above and beyond the inactive pill, then it's due to the ingredients of the active pill. If there's no difference between the sugar pill and the active ingredients pill, then it's the fact that someone has taken a pill that is causing that improvement in symptoms. So you can compare the two to see what's going on, and ideally you want the active pill to be more effective than the sugar pill. But there's a wide understanding that just the act of taking something you believe to be medication that will make you feel better will make you feel better, and that's a baseline that we understand as part of human nature. Double-blind experiments also work by basically ensuring that expectancy effects don't kick in for both the participant and for the person who's administering the drug. We'll talk about expectancy effects for the administrator of the drug in just a little bit, but that can kick in too sometimes with this type of study. And in double-blind experiments, both the participant and the administrator don't know whether they're taking the active drug or the placebo. So for example, in the study that I did where we were taking a look at social rejection and acetaminophen, we had a baggie of blue pills and a baggie of white pills, and we were told whether to give blue pills or white pills to any given participant, but only the lead experimenter knew which one contained acetaminophen and which one contained cornstarch. And so we were assured to treat both pills the same and to not have any unanticipated expectancy effects on our end, and participants would also have that placebo and would not know whether they were taking the placebo or the active drug, which is fairly standard practice in drug research. Let's talk a little bit more about the different reasons underlying the placebo effect, because it is psychologically fascinating. So one of the things that's happening is the expectancy that the subject has. So their expectancies can shape their interpretation of what they go through. If somebody truly believes that a pill will help them and that they will feel better, they might over-report mild improvements as being more of an improvement than they otherwise would be, as a method to please the experimenter, to show that the drug is working. They might feel obligated to help the research, and so it might come from a very good place in terms of what they expect and how they might blow something a little bit out of proportion. Also, once again, there's the very real phenomenon where if you believe a treatment is effective, then you can experience modest improved outcomes even if you're taking a completely ineffective treatment. There's some really interesting sort of research out there about how our expectancies can have an impact on something as basic as our immune system. So one of my colleagues, Suzanne Sagerstrom, who's at University of Kentucky, has done a lot of work on how optimism can actually boost immune systems so that people who expect positive outcomes tend to also have stronger immune responses to infections and to diseases and viruses, which is a really interesting sort of way of thinking about it. It's a little chicken and egg. It's hard to know what comes first. But the key thing here is that a subject's expectancy about their future outcomes can actually determine a great deal in terms of how they'll fight off illness. There's also the notion of conditioning. So, for example, some pain medication, when you take it, takes about 15 minutes for it to kick in and achieve peak effectiveness. Sometimes you might notice that when you take an Advil for a headache or something like that, that you tend to feel better a little sooner. And what happens with that is that your body's been conditioned to respond in a certain way and to associate medicine with relief. So the body might respond to any pill that you take as it does to other medicine and associate it with positive outcomes and then end up helping it along. There's also the notion of motivation. People who enter into drug studies often do so out of a profound desire to feel better. And their participating in research indicates they are more motivated and hopeful of the outcome and are taking active steps to improve their health. So someone who is in a drug study might once again have that extra drive and determination, which means that they are going to be more likely to respond positively to any intervention, even if it's intended to be a baseline or placebo. Once again, this goes down to our very biology. Research shows that when people take medication they believe to be pain relief, that natural opiates release in the body. So that our body is contributing to our pain management because we believe that we've taken something that will help. And so our body is fooled, once again, due to this classical conditioning and our own expectancies, to help us actually reduce our pain through natural opiates that have nothing to do with the pill that we've just taken that has nothing but cornstarch or sugar in it. So the placebo can provide pain relief if you believe it to be an effective method of pain relief because the body will respond with the release of natural opiates, which will make you feel better. Interestingly enough, when we block opiates with naloxone, the placebo effect doesn't occur, which is once again indicating that the placebo effect can often occur due to our body's natural responses to what it believes to be a helpful intervention. I also wanted to talk about other experiment effects, specifically from the point of view of the experimenter. So when the experimenter is looking at data, sometimes the experimenter can make errors. And the thing with those errors is that they're not at random, that humans tend to have biases, and that when an experimenter makes an error, it tends to be in favor of the hypotheses a little bit more often than going against an expected hypothesis. What do I mean by that? I mean that if someone's filling out a questionnaire and you can't tell whether their answer is a 1 or a 7, you're a little bit more likely to put a 7 if you think they're supposed to be high on the outcome, and a little more likely to put a 1 if you think they're supposed to be low on the outcome. So they did an actual study on errors and took a look at quite a few observations. They found a 1% error, and that 2/3 of those errors were in the direction of the hypothesis, as opposed to 50% if it was truly at random. So once again, this isn't an automatic. You don't automatically make errors in the direction of the hypotheses. You're just slightly more likely to. There's also the notion of interpreting behavior. So when examining from the outside how effective a therapy is, people might be more likely to overestimate the effectiveness of something when looking at it from the outside if they expect it to be effective. So once again, we can interpret behavior in a way that's shaped by our own expectancies. One way of combating this is by observing the effect size of a given phenomenon, which takes into account how strong it actually is. So you might say, this is so effective, but when you actually break it down into the effect size, which is a mathematically generated number, you can actually quantify how effective it is and whether it was a truly strong effect or a more modest effect. So this is a way to make it more quantifiable and less determination on our own personal opinions. We've already talked a little bit about effect sizes in statistics, and I mentioned it again recently in our semester in Intro to Design. But as a reminder, effect sizes are ways of indicating how large an effect is, and they're standardized. So you can compare effect sizes from different studies to one another and average them across multiple studies to take a look at the average size of a phenomenon. So if you want to know how effective a therapy is, you can take a look at 50 studies that explore the effectiveness of the therapy and average together their effect sizes in order to gain a really great picture about the overall size of the phenomenon and whether gains are large or modest. I nearly said significant. It's a different sort of thing. As a reminder, effect sizes are not an indication of statistical significance. They're just an indication of how powerful the effect is. And once again, it's a way of quantifying effectiveness instead of depending on opinion. Other types of errors that we see when we're looking at experimenter errors include intentional effects, where experimenters intentionally misrepresent their data. We've already talked a little bit about this with Dietrich Staple. You can imagine me shaking my fist right now at Mr. Staple. And sometimes people will engage in these intentional effects of misrepresenting their data due to the very strong pressure that some researchers are under to publish or perish. So we've already talked a little bit about some of the things that contribute to a tendency to misrepresent data, and that's kind of factoring in there. There's also occasionally biosocial effects. So sometimes the experimenter gender can interact with the participant gender in unexpected ways. If the experimenter is a different gender than the participant, that might lead to different results than if they're the same gender as the participant. And it's important to recognize sometimes that gender differences that you might see in an experiment might be due to the experimenter leading to differences in terms of how men and women might experience the study. Also, sometimes the personality of the experimenter can contribute to differences from the participants' perceptions. So if the experimenter is very warm and effusive or cold and robotic, that can lead to a different set of emotional responses. You can also have situational differences, so how experienced the experimenter is and how familiar they are with the script can determine how they might read through the script and the instructions that they give and the confidence with which they deliver their material. So if they've worked with participants before, or if they have previous knowledge of the participant because they might know them in another context, all those things can play a part. Expectancy effects themselves from the experimenter are fascinating. So expectancy effects from the experimenter are where the experimenter's expectations can shape how participants will respond. So for example, they've done a whole series of studies and exploring of this phenomenon. Let's go ahead and go through some examples. So when looking at experimenter expectancy effect, researchers, for instance, took some students who were working with rats on a project and pointed out certain rats at random and said that those rats were especially intelligent. And what they found is that people who were the students who ran the rats tended to handle the rats more and pay more attention to them, and as a result their performance on various mazes improved, not because they were smarter, but because they were treated differently by the experimenters. Clever Hans is the story of the horse who could do math. He would tap his hoof when people would ask him mathematical questions. And as it turned out, horses can't actually do math. I'm sorry, I hate to burst that particular bubble for you. But what Clever Hans was picking up on was subtle cues from the people around him who would tense their bodies or give him very subtle feedback to indicate he needed to stop tapping his hoof or he'd get the answer wrong. So for example, if someone asked a mathematical question that no one in the room knew the answer to, Clever Hans couldn't answer it, indicating that he was dependent on the subtle behavioral cues of the people around him, and he was paying attention to that. So their expectancies were shaping his response. The Pygmalion effect is also a famous study on IQ. I've linked it for additional reading if you're interested in learning more about it. But once again, children were chosen at random in an elementary school classroom, and their teachers were told at the start of the semester. So once again, at random, completely at random. Teachers were told at the start of the semester that these children were diamonds in the rough and could be expected to blossom during the course of the semester. And those children's IQ scores improved by about 10 to 15 points during the course of the semester, which is almost a standard deviation. And their grades also improved. Now, these children had been chosen at random, but the teachers were much more likely to engage with them in a different way because they believed those children to be exhibiting intelligence. They were more likely to see wrong questions or answers as being just kind of nosing around and a sign of intelligence as opposed to not understanding the content. They spent more time with them. They communicated with them differently. So a teacher or a researcher's expectancies can really shape how they interact with participants, which can change a participant's experience. The solutions to this are to train researchers to try to be as consistent as possible. But really just keeping into account the fact that experimenters are a potential factor in this and can interact with the participant in ways that we can't necessarily anticipate. It's just important to keep in mind as part of the factors at work.